Hello and welcome to video 5 in Module 7. In this video, we'll take a moment to determine how we can identify a problem as either a z-score problem or a t-score problem. The main thing we're going to look at is whether or not we have a population standard deviation. So when determining whether a problem will require a z-score or a t-score, you must identify whether the population standard deviation is known or unknown. And you can't take a shortcut with this. You can't just say, do we have a standard deviation or do I have a population? You can't do that shortcut because you are always making a prediction about a population. You will always have a sample mean. You'll always have a sample size. So you can't just think of words sample or population. You need to also link them with standard deviation. So we're looking for a population standard deviation or a sample standard deviation. That's going to be what we're looking for. If I know the population standard deviation, that means I know sigma. And if I know sigma, then I'm going to use a z-score. If I don't know sigma, that means I'm going to need to know S. And if I know S, that means I'm going to have a t-score problem. So sigma is going to be for a population standard deviation. If I know it, I get to use the z-score steps. And if I don't, then that means I need a sample standard deviation, I need an S, and so I'm going to find a t-score. So let's look at a couple of examples of just identifying whether we're going to need a z-score or a t-score to solve. In this example, a simple random sample of size 18 has a mean of 71.32 and a standard deviation of 15.78. The population is approximately normally distributed. If I want to construct a 95% confidence interval for the population mean, will I use a z-score or a t-score? Now, this is where identifying parameter and statistic comes in handy. That was also way back at the start of the semester. We're going to have to read carefully to see whether the information we were told is about a sample or about a population. When I look at that first sentence again, it starts out telling me about the sample. It says, a simple random sample of size 18 has a mean of 71.32 and a standard deviation of 15.78. So this is telling me that the standard deviation is about the sample. That means they're telling me an S. That S is 15.78. Since I know S, but I do not know sigma, that's going to make this a t-score problem. Let's do another example. Suppose that Herbie finds the price for a simple random sample of 8 types of windshield wipers and records the prices below. So these are prices of windshield wipers. Assume that the prices of all windshield wipers are approximately normally distributed with a standard deviation of $4.18. If I were to construct a 99.5% confidence interval for the mean cost of repairs, would I use a z-score or a t-score? In this case, we're presented with sample information at the very beginning because this is our sample that we're using. But after that, it then says, assume that the prices of all windshield wipers are approximately normally distributed with a standard deviation of 4.18. So this sentence after the data set is a sentence that's about all windshield wipers. It's not about the sample of windshield wipers, but the entire population. So the standard deviation they're telling us here is a parameter. It's about a population. In other words, we know that sigma is 4.18. Since we know sigma, that means we're going to need a z-score. This concludes our video for identifying z-scores and t-scores. In the next video, we'll be starting the next topic, which is called hypothesis tests. And those will help us to determine whether the result of an experiment is significant or not, whether it really marks like an improvement or something going on. So as always, thanks for watching and have a wonderful day.